Okay, there are three common forms of linear equations. All right, so start underneath that heading in the upper left-hand corner. The first one, and we should definitely know this by now, is the slope-intercept. Okay, and again, the slope-intercept form of a linear equation. So again, we're going to have, so you can even do this right now, we're going to have three common forms, actually. Leave a little bit more space for this last one because we're going to need a little bit more room for that. I got my column a little too short. So the slope-intercept equation, we all know this. Write it down. What's the equation? Y equals mx plus b. All right? And what we need to do is fill in the slope, fill in the y-intercept. Okay, so an example of this would just be something like y equals 3x minus 4. Okay, worked a lot with that already. You should know that. Second common form of a linear equation, again forms a straight line, is called standard form. Okay, standard form equations look like this. This is the format. ax plus by is equal to c. Okay. Now, if you have an ordered pair, the x, this is the x and the y. Okay, an example of this would look something like this. It would be something like negative 5x. Then we can do like plus 6 is equal to, plus 6y. Okay, is equal to, let's just say 7. So negative 5x plus 6y is equal to 7. So the a and the b up here, those are called what? What are the a and the b actually called? Numbers in front of variables are called coefficients. So the a and the b in this equation right up here just represent the coefficients on the x and the y. That's it. Okay, the last one is point slope form. Okay. This is a useful equation if you are given a point and the slope. And the standard form of this looks like this. So y minus y1 is equal to m parentheses x minus x1, close parentheses. Okay. Now, the y1 and the x1, we oftentimes use this little, like we call it sub 1, to represent something that we know. Okay? So if we have an ordered pair, an x and a y, this y goes in for the y1, not the regular y, the y1. Again, it represents something that we know. And the x1 represents the x that we know. Okay, so this is, say this is like a given point for us. Okay, if we know a point, we can substitute in for the x1 and the y1. So let's do a quick example of this. And you're going to need a little bit more room for this one. In fact, I'm going to go to the next page. I want you guys to continue this work right here, okay? But I'm going to go to the next page so that way I have more room. Okay, the example is if you have something that says like through the point negative 5, 7 with a slope of 8. So again, the question might say something like, and listen, okay, so stop writing for a second. The question might say something like, you have a line that goes through point negative 5, 7 and has a slope of 8. What is the equation? Okay, we can use the point slope equation to help us out. Again, the equation was y minus y1, and memorize this is equal to mx minus x1. Okay. Now, again, the y1 and the x1 represent a point that we know. So we keep the y minus y1, this is So the x and the y, right? The y that we know is 7 is equal to, we also know the m. The m is 8. Parentheses x we keep. The x1 is the x that we know. Well, the x that we know is -5. Okay. Now we can simplify. So y minus 7 is equal to, I'm going to do this, and I want you to show each step too. X, what's minus a negative turn into? X plus 5. And then we can continue simplifying. Y minus 7 is equal to, distribute, 8x plus 40. Okay. Now, if we wanted to solve for y, like if it said convert it to slope-intercept form, we just have to get y all by itself, which means we simply have to move this -7 to the other side. So y is equal to 8x, and we only combine the 7 with the 40 because they're like terms, plus 47. Okay. So I just wanted to show you that we essentially started with the point-slope form, and we can convert it to slope-intercept form. We can convert any of these equations to the other ones, okay? And we'll go through another example of that. All right, hello there, mathematicians. This objective is students will be able to solve literal equations, I just abbreviated that, and convert to slope-intercept form. Okay, hit pause, get that down. Okay, let's get example 1 down. So example 1 is y minus 3x is equal to 5. Okay. Now, I look at this, and the directions for this would say something like convert to slope-intercept form, or rewrite to be in slope-intercept form. And I know that in slope-intercept form, the variable that is all by itself is the y, because it's y equals mx plus b. So essentially, all I'm having to do is solve for y. Okay, whenever I'm solving for a variable, we already know this, I always ask myself the same question. What is being done to that variable? And what is being done, okay, I fill in the do side. So if I say this left side out loud, this side with the y minus 3x, okay? So what did I say? I said minus 3x. So I'm going to write down what's being done on the same side. I am subtracting 3x. Okay. Now, a common question here and a common misunderstanding is, Mr. Irwin, why do we put this x over here in the do box? Because typically we don't, right? Here's why. Do you want this x right here? Do you want that to stay on this left-hand side of the equal to sign, or do you want it to go to the right-hand side? And the answer to that is, well, if I'm going to get y all by itself here, I need to move this entire negative 3x to the other side. I need to move it. Okay? Well, how do I move a negative or a minus 3x to the other side? I'm going to add 3x to both sides. So I'm going to add 3x to both sides plus 3x. Okay? So now I'm going to rewrite it. What happens to this? This cancels, right? Y equals 5 plus 3x. Now, is this equation in slope-intercept form? Almost. But remember, in slope-intercept form, and you don't have to write this down because you should know it, y equals mx plus b, right? In slope-intercept form, the coefficient on x and x comes first, the y-intercept comes last. So I simply have to take this y equals. Now this is so important, you guys, especially when we get to where we have a subtraction. I have to look at the sign on my 3x. And my sign on my 3x is a plus 3, right? So that tells me that it's going to be just a positive 3x. Okay. What's the sign in front of this 5? Well, there's nothing there, so I know it's a positive, right? Because it's a positive, okay, I'm going to write plus 5. Okay, that's where we get the signs from. We always look in front of the number or in front of the term. Okay, this equation is now in slope-intercept form. This is your answer. All we had to do is solve for y. Okay. Now, really quickly, I want to show you why, and don't write this down. You guys can just watch this. Okay, actually, go ahead and write this down. You should have room in your notes. If you said, oh, I need to divide both sides by 3, okay, because you think, oh, 3 or negative 3, because negative 3 is touching my x, so I got to divide. Okay, watch what I do when I divide by negative 3. Okay, divide by negative 3. And again, I want you to show this work, and then we're going to cross it out because it's wrong work. What happens when I do that is this. This cancels, but does the x cancel? No, it does not. Okay, because I didn't subtract that x too. So I would be left with y, actually be y over negative 3, okay, minus x is equal to 5 over negative 3. So again, I have y over negative 3, okay, minus x equal to 5 over negative 3. Did that get y all by itself? No. So if you thought, oh, I need to divide by 3, you should see right away, okay, that's not actually going to get this y all by itself, like it does if we just add 3x to both sides. Okay, so cross this out because that is not y. And if you need to make a note, like if you thought, oh, I need to divide by negative 3 up here, okay, and not the x, then you need to make a note on this problem about y dividing by negative 3 does not actually solve and get y all by itself. Okay, so go ahead and hit pause and make a note if you need to do that. Okay, let's do a few more examples. Example number 2. It would be, let's do 8x plus 2y is equal to, negative 4. Okay? Alright, so, and again the directions would say convert this to slope-intercept form. And I know slope-intercept form, I'm solving for the variable y. I have to get y all by itself. Okay, whenever I'm solving for any variable, I ask myself what is being done to that variable. Okay, and if I look at this, I have something touching the y. Okay, what's touching it? Well, I know touching means multiplication, so get that down first. And what's touching it is a positive 2. So we could say that I'm multiplying by a positive 2, or just multiplying by 2. Okay, how do I undo multiplication by 2? I divide by 2. Okay. What else is on the left side, or on the side of y? Well, right here, I have a positive 8x just hanging out on the same side of y. Okay, I need to get this positive 8x to the other side. Right, I need to move it over there. Well, how do I cancel a positive 8x on the left-hand side? I simply need to subtract 8x from both. So what was being done is I have a positive 8x. How do I undo a positive 8x? I subtract 8x. Okay. Now, here's another common question. And here's what I hear students say all the time. But Mr. Irwin, the 8 is touching the x, which means it's got to be multiplication by 8. Okay? What variable did we say that we're solving for? Are we solving for x or are we solving for y? We're solving for y. Okay? Is 8 touching my y? And the answer is no. Okay? We're not asking what's being done to x. We're asking what's being done to y. Okay? And what's being done on the same side of this y is just this positive 8x is hanging out over here. We need to move it to the other side. Okay? Now, if I use reverse GMDAS, it's going to tell me, again, reverse GMDAS, because I want to get this down as a reminder. Okay? When we are simplifying, and I want you guys to get this down again, when we simplify, we use regular GMDAS. But when we solve, we use reverse GMDAS. In this case, we are solving for a variable, so we need to use reverse GMDAS, which tells me, okay, well, I need to subtract 8x first. Okay, whenever I add or subtract, I do the upside down t. Subtract 8x. Now, I did not mention this on the last example. Let me go back. Let's just stick with this one. Okay, we should have known this on the last one. So 8x minus 8x over here, cancels. Negative 4 minus 8x. And I didn't do it on the last one. Can I put these together and say, oh, that's negative 12x? And the answer is no. Think to yourself, why can't I do negative 4 minus 8 and just say, oh, it's negative 12x? Think about that. Okay. The answer is they're not like terms. Okay. And I think it would be helpful to put a note, and you guys have more room on your paper. Okay, but put a note and just put not like terms. We cannot combine those because they're not like terms. Okay. Now I'm just going to rewrite this. I'm left with 2y is equal to. Okay. Now right here, if you want, you know that your x term is going to have to come first before your regular constant number. So what I'm going to do is I'm just going to rewrite it right now. That way it's already kind of in slope-intercept form. So I look at my term with the x, and I see that it's a minus 8x. So that tells me, this minus tells me it's going to be negative 8x. And then this negative 4 here tells me that's going to be minus 4. Again, you have to keep the signs in front of your terms. You have to. Okay. Now, did I solve for y yet? Not quite. I just did that. But now I see I need to divide by 2. Now watch how I do this, because this is incredibly important. I want you guys to just watch, and then when I'm done you can hit pause and get the actual work done. But I want you to really watch and just listen. Okay. So I need to divide the left side of my equal to side by 2. Okay. Here's the key. You need to divide the entire right side by 2. Okay. Now here's how I like to show this though. Actually, I'm going to show you one way. So I need to divide both of these terms. And I want you guys to circle this, because we have got to simplify both of these fractions. Okay. So 2 over 2 cancels, leaving me with just y. Okay. And then I'm going to rewrite this just so that we can see it. And you guys should too, so you have some really good notes. What this actually looks like is it looks like negative 8x over 2. And then it also has negative 4 over 2. Okay. So now, when you simplify these two fractions, a negative 8 divided by a positive 2 is going to give me a negative 4x. Okay. And then a negative 2, or a negative 4, I'm sorry, divided by a positive 2 will get me a negative 2, and I can show a negative 2 as just subtraction of 2. Okay. Right there, I just converted this equation, the starting equation, to slope-intercept form, and I know that because I have y equals mx plus b, or y equals some number x plus or minus some other number. So this would be my answer to this example. Okay. Again, if you have questions, make sure you hit pause, write exactly where you have your questions at. Okay, let's do another example, example 3. Okay, same type of thing, it's just this time the signs are a little bit different. But again, the directions are going to say convert this to slope-intercept form, or write this equation slope-intercept form, which tells me I know I am solving for the variable y. Okay, so I'm going to ask myself, what is being done on the same side of my y? Well, I like to always start with what's touching it. What's touching my y? Well, I have, and don't make this mistake, is it a 4 touching my y? And the answer to that is no. You have to look at the sign in front of it. It's not a 4 touching y, it's a negative 4 touching y. So on both sides I'm multiplying by negative 4. Okay? How do I undo multiplication by negative 4? I divide by negative 4. Okay. What else is being done on the same side of the variable? Well, I just already accounted for this part right here. Like, I just accounted for that, right? I said I'm multiplying by negative 4. So what else is over on the same side of y? Well, I have this positive 2x over here. Okay. How am I going to move this positive 2x to the other side? Very simple. So I'm going to write this down. I have a positive 2x hanging out. How do I move the entire positive 2x? I need to subtract 2x. Okay. Again, it's not that I'm multiplying by 2 because 2 is touching x. I'm not asking myself what's being done to x. I'm asking myself what's being done for y because I'm solving for y. Okay, so on both sides, I'm going to subtract 2x, subtract 2x. Why did I write these sideways, 6 minus 2x? Well, they are not what? You should be saying it. They're not what? Like terms. They cannot be combined. So, and cancel this. Now, I'm going to tell you the most common mistake is this. Students will say, okay, I'm going to bring down what's left. Boom, 4y. Take a second. What's wrong with what I just did? Okay, you should have told yourself, what did I forget? I forgot to bring down the negative sign, or the minus, which I know is a negative. Okay, I want you guys to put a big note here because I want us to avoid this mistake. That a common mistake is forgetting to drop negative, or you know, it was subtraction, but subtraction is the same as a negative. Forgetting to drop negative sign. Do not make that mistake. Okay, so again, put a big arrow showing, oh, I dropped that down. Okay, and then what's left? Well, I'm going to rewrite this so that my x term is first. Okay, so here's my x term. What's the sign on this x term? Again, you always look in front of it for the sign. It is a negative 2x. Okay, what's the sign on my constant here? Well, if nothing's in front of it, I know it is a positive, so it's going to be plus 6. Okay, and again, if it helps you, put an arrow showing that's where I got the negative, and then here, because it's a positive, you can put an arrow showing, oh, that's where I got the plus. Okay, again, this is just good note-taking so that you know where these things came from. Okay, and then if I look at this, I just finished that. I said I need to divide both sides by negative 4. So I'm going to divide by negative 4. Now, here's the way I actually would like you guys showing your work. I need to actually divide both of these terms by negative 4. So here's what I like to do. Separate your terms, okay, by putting a bar before the plus or minus sign, and then just show two different fractions, both of these being divided by negative 4. Okay, both those being divided by negative 4. So when you do that, negative 4 divided by negative 4 cancels, leaving me with just y. The y doesn't cancel, okay? And then a negative divided by a negative, okay, will get me a positive. So negative 2 divided by negative 4 will give me a positive, but I also have to simplify that. 2 over 4 simplifies or reduces to be 1/2. So I have 1/2 x, okay, and then 6 over negative 4, okay, a positive divided by a negative will get me a negative. So because it's a negative, I can just write subtraction. Again, a positive divided by a negative here, I missed that, will get me a negative, so I'm just going to write minus, because a minus is the same thing as a negative. 6 over 4 simplifies or reduces to be 3 over 2. Okay. Now, one thing if you remember, okay, do we ever want our y-intercept to be an improper fraction, this 3 over 2? And the answer is no, because if I go to graph 3 over 2 on a coordinate plane, I don't really know what that is unless I convert it to a mixed number or a decimal. So I'm going to rewrite this y equals 1/2 x minus 3 over 2. It would be 1 and 1/2. Or, again, it can be a decimal just for the y-intercept, right? Y equals 1/2 x minus 1.5. Either one of these two would work for this. Either one of them. Okay, two more quick examples. Example 4. Again, with these examples, I'm trying to show you like all the different weird combinations that you could run into. Okay, so example 4 is y minus 2 is equal to 1/2 x, 1/2 parentheses x plus 5. Okay. All right. So when I look at these, it's really important that the very first thing before you say, oh, what's being done to the variable, is you got to make sure both sides are simplified. We did this with multi-step equations. The number one step was to make sure both sides are simplified all the way. And oftentimes to simplify, we need to distribute or combine like terms. Okay? So if I look at the left-hand side, y minus 2, that can't be simplified because they're not like terms. But the right side, I have a number touching parentheses, which I know I need to distribute. Okay? And to distribute, the steps I need to show, we've already gone over this. First of all, put that hidden 1 in before the x. Separate your terms by putting a bar before the plus or minus sign. And then show this distribution to each term. Okay, so I'm going to rewrite it. Y minus 2, I didn't do anything with this left-hand side, is equal to, well, what's 1/2 times 1? 1/2 x. Anything times 1 is just itself. We got to know that. Okay, and then 1/2 times 5 would be, let's see, so plus a positive times a positive is a positive, so I'm going to write plus, and then I could write this as 5 over 2, but I know it's going to turn into my y-intercept because it's just the number. So instead of writing, I think, 5 over 2, I'm going to write 2 and 1/2, or I could have even written 2.5. Okay, either one. Alright, so now I am going to ask myself what's being done to y, and if I look on what's being done to the side of y, I see it's y minus 2. So what's being done? How do I do it? I am subtracting 2. How do I undo subtraction of 2? I need to add 2 to both sides. Okay, so I need to add 2. Now, okay, don't write this down yet because I want you to just watch. Which one would I show here? Would I do plus 2 right here or plus 2 right here? Okay, which one? The first one or the second one? And I want you thinking about why. Okay, take about 10 seconds to make a decision and think about why. Okay, if I look at this first one, I have 1/2 x plus 2. Right away in my head, I should be thinking, well, those aren't like terms. I can't add those. This one has a variable, this one does not. Okay, so you cannot add these. You cannot add those. They're not like terms. And if you, again, if you need to make a note, put an arrow over here in the margin and put like not like terms, can't add, go ahead and do that. Okay, the positive, the plus 2.5 plus 2, I can definitely add those. They're just regular numbers. Okay, so I'm going to rewrite this. Y, the minus 2 and plus 2 cancels. I'm left with y equals, okay, 1/2 x doesn't change because I didn't combine it with anything. And then the 2.5 plus 2 would just be plus 4 and 1/2. Or you could write the y-intercept as a decimal, 1/2, y equals 1/2 x plus 4.5. Okay, either one of these two would work. Either one of those. Alright, last example. Let's go on to it. Okay, this is the final example, example number 5. It says solve for w in terms of p. Okay, when I read this, all this wording can kind of be tricky, but just read and think about what you know. It says solve for w. How do I solve for w? I need to get w all by itself. So if I'm going to use cups and actively read this, solve for w, I know that w, I need to have something that's w equals, right? Now this in terms of p, okay, simply means that you're still going to have p in your equation. You're actually going to be left with two variables still. Just like how we had in the last few examples, in the final answer we had both a y and an x. Okay, this time we're just going to have a p and a w. And again, we're solving. It's really important that we know which one we're solving for. We're solving for w. Okay, so the very first thing that I should always do when I look at equations is see if I can simplify either side of the equation before I go moving things from left to right side. And if I look at this, I see right away I absolutely can simplify a few things. 5p and 2p would be 7p because they're like terms, is equal to. If I look at this, I'm going to use a different thing because these, the p and the w are not like terms, so I'm just going to use boxes. Okay, 2w minus 3 will get me negative 1w, and then I just have plus 8. I didn't do anything with that plus 8. Okay. Now, both sides are simplified. So now I can go ahead and ask myself, well, what's being done to my variable? And careful, which variable do we care about? Do we care about the p? No, we're solving for w. So I ask myself, what's being done to w? Okay. And if I look here at this w, I see, well, what's touching my w? Again, what's touching my w? And I see a -1 touching my w. And again, you cannot have a -1 in front of your w. You can have a +1, but you can't have a -1. So I would say I'm multiplying by -1. How do I do that? I'm going to divide by -1. Okay. What else is being done? Well, I have this plus 8 here. Okay. So how do I undo a plus 8? So what's being done? I am adding 8. How do I do it? I subtract 8. Which one do I do first and why? Do I subtract or divide? You should have said I need to subtract first because I'm using reverse gymnast. So I start with addition and subtraction. So on both sides, I just told myself I need to subtract 8. Subtract 8. Okay. Now, common mistake, 7p minus 8 would be, here's the common mistake. Oh, it's -1p. Right? 7 minus 8, -1, keep the p. Okay, these are not like terms. You cannot combine them or you cannot subtract them. So you simply have to leave it as 7p minus 8. That's how we need to write it. You can't combine those. And that equals, okay, this canceled over here, that equals -1w. Okay, so now we just finished that. Okay, so I look at my undo. I said I need to divide both sides by -1. By -1. And remember, you have to divide each of these terms by -1. Each of these terms by -1. Okay, so I'm going to be left with -1 divided by -1. Negative divided by a negative cancels to be a +1w, which is exactly what I want, right? The +1w. Do I need to show that 1 in front of w? No, you don't need to, but you can. Okay, and then if I look over here, a +7 divided by a -1 is going to get me a positive divided by a negative will get me, I'm going to make that positive that way I don't confuse it, will get me a -7p. And then a -8 divided by -1 will get me a +8. So I'm going to write +8. Okay, I just solved for w. I have w all by itself. Okay, that is my final answer. W equals -7p plus 8. Now, if you want, you can rewrite it so that's this way, -7p plus 8. You can rewrite it. Oh, that's an ugly 8. So that this w is on the left-hand side, which I know a lot of you like to have the variable that you solve for on the left. That's fine. Doesn't change anything. Okay. All right, I'm going to give you guys, I think, just 3 practice problems so that you can try them, and then I'll give you the answers on the final slide. Okay. Okay, here are your 3 practice problems. Be sure to get these 3 written down. Maybe leave room for some space, or you can just hit pause now, do one at a time, show all your work. Once you're done with all 3, you can unpause it, and I will provide the answers for you on the next slide. Again, make sure you do them first, and then if you get one wrong, make sure you go back, find your mistake, and explain what mistake you made. That way you come to class prepared, ready to master this objective. So go ahead and hit pause now. Okay, here are the answers to the 3 problems. Again, make sure you really check the signs. If you got anything wrong, mark it wrong, that way you know. For when you come to class, and then also be sure to try to find your mistake and explain what mistake you made.